Hi, this is Tom, and in this lesson we are going to learn about what is called the logarithm. So I'm going to write that out for us. This is the logarithm. That's our lesson. Now, I've actually brought back into this picture. I'm going to turn off the graph paper, kind of a bit much. And what I want to look at now is, oops, I want my eraser. I have some extra dots here, but I've brought back this picture that we drew of the graph of f of x. So this red graph here, this was the graph f of x equals 2 raised to the x. For example, and let's look at a few of these points. For example, when I put in f of 3, this said 2 raised to the third power is 8. And then let's try it. We'll do 3. When I put in f of 2, that gave me 2 squared, and so that was 4. And that's this one right there. And let's do one more. Let's do 0. F of 0. We said, well, that's 2 to the 0, and anything to the 0, well, that's just 1, and we got this point that crosses at the y-axis. Now, we know that if we had the ordered pair, this from the red graph, 3, 8, or the point 2, comma 4, or the point 0, comma 1, we knew by the property of inverses, and I'm going to write it this way, and we're going to use this double arrow. In mathematicians, it means if and only if, or if one side's true, then the other has to be true as well. But the symbol is if and only if. And you'll see, oops, you'll even see some mathematicians will use the double arrow, and if they're writing, sometimes they'll write if with 2 F's. Is another way to write if and only if. But remember what we knew. We knew that if there was an inverse, all it would do is take the 8 and return the 3. Or it would take the 4 and return the 2. Or it could have taken the 1 and returned the 0. So wait a minute. Let's see how this works. So I'm going to give myself a bit of space. And so this is what we know. We know that if we have some inverse function, we don't know what it is, but we're going to in a moment, whatever it is. For example, I know that if I put f inverse, if I put in 8 in this problem, I should return 3. And the question then is, what is this that gives me back the 3? And the answer is in the title to today's lesson. It's the logarithm. And it's written this way. So the function, the inverse function, this is a brand new function for us, is the inverse of 8 equals the log. Log is short for logarithm. It's the log in base 2, written as this little subscript, of 8. And we know the output, we just wrote that above, that's 3. So here, if I go down here, I know that if I put in my inverse, if I put in an 8, I get a 3, and that comes from the inverse function, which is the log base 2 of 8. And in the next one, I know that if I put in a 4 into my inverse function, I should get out a 2, and I do when I use the logarithm in base 2 of 4. And finally, we also know that if the inverse, we put a 1 into the inverse function, we know it has to be 0, and the process, the actual function, is log base 2 of 1. That's what's going on. That's what the logarithm is. The logarithm is the inverse function of the exponential function. Well, let's write that because that's pretty important. So the logarithm is the inverse function of the exponential function. And so in general, for example, now when I have a problem f of x equals 2 raised to the x, well, if and only if, then we know that the inverse function is going to be log base 2 of x. Now let's try this. In general, what if we just have any base? And so to represent any base, we usually use b. So what if I have some base raised to the x? Well, then what I know is going to be true is that the inverse function of this, and in general, is the log in that base of x. And so now, if you know the exponential function, you also know its inverse function. And so now we can write this relationship anytime. For example, if I have 3 raised to the 4th power, I know that that's 81. But I also know then, it's also true that the log, and notice the base is 3, so that log in base 3 of 81 gives me back the exponent, which is 4. Let's try another one. Let's try one more. How about this one? How about e? Yes, e raised to the 0 power. Well, we know that any number to the 0 is 1. So if that exponential form is true, then there also has to be a corresponding logarithmic form. And so in this case, we'd write the log. And notice that the base is e. See, notice that the base always turns into the subscript here. It does it on each one of these problems. So again, e becomes my base. So log base e of 1 equals the exponent. Okay, now, we're not quite done when we use log base e, because log in base e is special. And by that what I mean is it's primarily used in modeling natural growth and decay problems. And because of that, because it fits so many natural phenomenon, we actually call it the natural log. And so it looks kind of funny. So from now on, when you see the log in base e of some number, we'll call it y. Or x. We'll use y. I'll use x to be consistent. Sorry. Log base e of x. We usually don't write log base e. What we write is ln of x. I know you don't even have to write the e anymore. And if you look on a calculator, you'll usually see a log base b or a log function, and you'll see an ln button. And the ln button is the log in base e. There's one more. Another one that's quite commonly used. Let's say we have 10 raised to the 3rd power. Well, that's 1,000. So let's do this. Let's write 10 to the 3rd equals 1,000. So this is the exponential relationship. So we know that the logarithmic relationship is log in base 10 of 1,000. And that would equal the exponent, which is 3. Now, log in base 10 is also special. Log in base 10 is also special. And how special is it? It's so special that instead of writing log base 10 of x, we simply write log of x. And the 10 is implied. So now, if you look on your calculator, you're going to see two log buttons, and you'll see these two. You're going to see ln of x for the natural log, which means log base e, and you'll see just a log button, and it's this one. It's log base 10. And the problem is if you have log base 2 or log base 3, like we saw up here, your calculator does not have that button. But there is a way to still do that in your calculator, and we'll be looking at that in another lesson. But for now, we have we've seen the general form of any logarithm, an exponential function. They're attached by this relationship, and that these two, the natural log and log base 10, are buttons on your calculator. Hope that helps. Thanks for watching.